Thanks. So this is lazy load to launch fast, how to improve the launch time of your app and delight your users. Now, the first thing to ask yourself is, why is launch time important? Why do we care about it, and why is it something that we should improve? So this is the first impression that you give to your users of the app. When they download your app for the first time and they launch it after downloading it, this is the first time that you get to make an impression. So waiting a long time or even a little bit too long for an app may give the impression that something is wrong or that something is not right with your service, with their user's phone, etc. And users could potentially drop off and just not use your app if these launch times are slow. Now you might say, well, yeah, but it works well on my device. It's fine. I use it every day, and our product owners use it every day, and everything looks fine. But you're kind of a bit of a special group here, right? Because you probably bought the latest iPhone or have the latest iPhone, and you're not really representative, or you may not be representative of your users. So it's for this reason you should get to know, the first thing to do is to get to know what devices are actually using your app. So let me give you an example of our app, ImmoScout. This is a real estate portal that is servicing mostly Germany, and it's where users can find objects or apartments to rent and buy, properties, and along with a whole bunch of other services. So this is really well used in Germany. This has 1.5 million monthly active users, and it's also quite old. The first commit is on Monday, April 4th, 2011, like 9 years ago. And we have nearly 20 developers working on the iOS app alone, and over 50% of it is written in Swift. So what kind of devices are actually using ImmoScout? This is a result from New Relic. You can see that it's pretty fragmented, but there's this other category here that we have. It's 20% of our users are using devices that aren't even listed on in this list. So 45% of our users are on iPhone 7 and below, and that may not be representative of your app, but you should know what these numbers are in order to get in order to use the app in a way that many of your users are experiencing it. So for our improvements, we want to actually set a goal. So Apple recommends a 400 millisecond launch time for iOS apps, and this is pretty lofty. This can be pretty lofty, depending on your app. For example, ImmoScout is a large app. It has a lot of features. It's something that there's a lot of code to load and a lot of dependencies. So you may think, okay, this is not even possible for our app, or maybe it's definitely possible. We're already launching at this speed, but I think you can get closer to that result than you think if you want to. So first, let's start with some technical terminology. You may recognize these terms from another WWDC video. I also stole the emojis. Very clever of me. And so this is what we would call the first type of app launch is cold start. And this is when the device has been rebooted, all the caches are cold, the app is not in memory, and no process for your app actually exists yet. So that's really not an often, you don't encounter this very often, but it's typically the slowest way to launch your app. And then there's a warm start, which is probably what the majority of you or your users experience, where the app was recently terminated, some dependencies might be in memory, but still no process exists for your app on the system. And then there is the resume case. This is just when you've switched an app, the app is still within that window of, I think it's 90 seconds now, that the app is still active in memory and can still actually get compute time. And then also, these are the stages that we'll talk about, the two stages that we'll talk about today, starting from launch from Springboard, and then into the which starts the system into this pre-main loop segment, which basically is where where the system will find the dependencies for your app, map them into memory, run the initializers, initialize the runtime, and then execute your main function, which is the entry point to your app. And then after that begins the active state, which is where the application did finish launching, gets called, and then finally your actual app code gets called as well. So let's talk first about the pre-main stage. How can we measure success with the app launch? The kind of conventional wisdom that if you haven't looked at this recently, or if you looked at this tried to optimize this a long time ago, is that dyld print statistics as an environment variable in your scheme is the way to get this data out of the launch process. So this is just an environment variable that you add to your scheme. You just put this in, you set the value to yes, or actually you can set it to anything as long as it's set. And then this logs the following console output after you've launched your app. So it shows like the pre-main time, the total pre-main time, how long it took to load the dylibs, rebase and binding in memory, Objective-C setup time, in runtime initialization, and then it gives you a list of the slowest initializers. Now, this is kind of crappy, right? Like this is not exactly something that we can use, like we can use test data or instrument data. So it doesn't really give us data in a convenient format that we can, store into somewhere and then compare it later. So it's not really ideal. But over the summer at WWDC, Apple has announced something that will solve our problem with Xcode 11. And that is the app launch template in instruments. And this is a really great improvement for anyone who's been using the previous method, which was kind of the standard for a long time. So, as you can see, this is just something that's available in the standard stock library of templates that's shipped with instruments. If you just build your app for profiling and then launch it, you'll see this screen. If you're familiar with instruments, this is probably totally familiar to you. So you just select this and on you go. And this is a segment of the app launch template that you'll see in instruments. And as you can see, this is really nicely done. It breaks it down. It breaks down the segments of application launch. So the first part is the initialization, and then the part there are other parts that are a little bit, they're too small to see, but it's like runtime initialization, and then the green section is after your app delegate method, and then after that, following is just your app code after that. So now that we've got our tools, we can get started on improving something. But how do we do that? So as an Apple engineer who, I forget his name, but the guy who's working on dylib, he said multiple years in a row, do less stuff. Now this is kind of like, great, that's not really helpful. But the fact is that we actually can do this. And how do we do this? So first let's check out what's really going on in this pre-main phase. So here's a screenshot of the larger instruments screen. And what we see here is that we got a lot of time spent overall, 373 milliseconds, in a symbol called dyld start. Now this also happens to be our heaviest stack trace. In instruments, it's really nice if any area of the profile that you've selected will be, the heaviest stack trace will be displayed in the lower right-hand pane, and this one happens to be it. So it seems to be pretty busy with that. Turns out dyld is doing a lot of work, but what is it doing? And also, what is dyld anyway? So dyld loads your dynamic frameworks. It loads dependencies that you've specified in your app, in a manifest in your app at build time to the system. So these dependencies are prepared using dyld. Now, before iOS 13, we were using dyld2, and this version of dyld was running in process inside at the same time as your app, rather than alongside your app. With iOS 13, dyld is demonized and is managing a cache of launch closures. Launch closures are the minimum amount of data that or executable data that your app needs to actually start. So this is so the new thing is that it's not running in process. So it's less intensive, and that it's also managing this cache of launch binaries essentially. Now, dyld can be used by code in your app to load frameworks using dlopen. And I'll get to that in a bit, but most of what we're talking about here, in fact, all of what I'm talking about here, is the app launch, the usage of dyld during app launch. So, you've probably got some dependencies in your app. We definitely do. We have over 70 third-party CocoaPods. I am not bragging here. This is not something to be proud of, but we do have a lot of dependencies. And they are all packaged as dynamic frameworks. And each of these frameworks must be loaded by dyld into memory at launch. Apple recommends that only about 6 maximum should be loaded. Now, this seems like if you're really heavy using CocoaPods and you really rely on a lot of stuff that you find in CocoaPods, I mean, this seems kind of ridiculous, right? Like, how could we possibly do this? I mean, especially since this is expensive. So just to give you an overview of, just a general overview of what actually happens when your app is launched and when dyld is executing. And this is applying for both, this is a generalization of dyld2 and dyld3. So it's not totally spot on, but basically it recursively finds dependencies needed to launch the app. This is contained in a manifest that your app provides. It maps those dependencies into memory. It calculates pointer addresses for those symbols that are loaded. This is called binding and rebasing. And it runs initializers for your Objective-C symbols and for the runtime. And then it executes the main function, or then the main function is executed. So this has been improved with dyld3. If you look at the WWDC videos, they really explain like why this is a lot more improved, and you can actually see the improvement for sure. But I think Apple knows that a lot of people are using things like CocoaPods very heavily, and they know that this is a huge point of improvement. So they have actually made improvements to launch time with dyld3. Like I said, the app launch closures are cached on disk, and the cache will, I think I'm not actually 100% sure, but I'm pretty sure the cache sticks around for quite some time. So like between app launches, this cache will be available to dyld when it's launched from a terminated state. But it still can be pretty expensive. I mean, it still doesn't come for free. But let's just make this easy and take dyld out of the equation. Let's just remove that entirely. So how can we do that? We can forget about all the pointer arithmetic and I/O needed by an in-process utility or daemon, and we can just load it all at once. And what we can do is replace our framework dependencies with static libraries. Now, this kind of sounds like counterintuitive. It sounds like it's going back. It's regressive. That Apple's been pushing dynamic frameworks so much, and it made a lot of advances here. But really, this is a big win for your app launch time. I mean, it really yielded the best results that we were after with this optimization. So we tried to remove as many frameworks as we could, and so should you. And also remember that this is possible because of changes that were made to Xcode 9 and CocoaPods 1.5.0. And even though I might say, yeah, it's okay, it's kind of a little bit seems regressive to use static libraries and whatever, static libraries were not supported, Swift static libraries were not supported until Xcode 9. And so Apple actually has been addressing this by adding this support and making it, I believe it's also available on the Swift package manager as well. I was talking about that earlier. But so it's something that it's not something that's totally old. And also Swift static libraries perform or are nicer than Objective-C ones. So they might be a bit new to you anyway. So how do we do this? If you're using CocoaPods for dependency management, like we are, I don't know what the split is if you're using Carthage or CocoaPods, and now I guess Swift Package Manager, but we are using CocoaPods. And another piece of conventional wisdom, if you've been developing with CocoaPods for the last 5 years, is to use this line at the top of your pod file, use frameworks. And that basically tells CocoaPods to package all of your dependencies as dynamic frameworks for your app to load. So you should remove this line in your pod file. Take it out. And then for your internal dependencies, it's just a matter of creating a new target in your project with the static library template, adding the source files to this new target, and then linking that binary in your main project. So basically, the way that you may be packaging your embedded frameworks at the moment is like this. So here you have your main app module. This is your code, your app's code, and it's sitting alongside. It's packaged in the .app package alongside with the embedded dependencies, and these are the binary files, the .framework files that are loaded at launch time. And we want to create a monolith instead. We basically want to take the main app module and package all of the dependencies along with that binary. So these static libraries are sitting right next to, or they are sitting in the same file as your app code compiled. And this means that all of the computation that needs to be done as to like where to put these dependencies, where the symbols are, where the addresses are, it's all been done at compile time rather than at launch time. So it's you kind of front load the computationally expensive part of this task to the compiler. Now, I mean, I say like, oh yeah, just remove this line from your pod file and like you're all good and your launch time is amazing and we can all go home now. But no, it's not really that simple. There are definitely disadvantages or the things that you'll need to do in order to get this to work properly. I mean, it's a first step to remove that. Just take a first step. You will probably have issues, as we did, with dependencies that are not converting properly. They may be, for one reason or another, kind of either consciously or accidentally exploiting the advantages of, or some quirks of, the differences between static libraries and dynamic frameworks. Your code will definitely have to be fixed up. But you can just do this first and then try to build. And it's this kind of this upgrade process. It didn't take us too long, but it can be a bit frustrating, especially since the compiler, be ready for the compiler to not really give you such nice errors and help as a compiler is usually doing. Okay, so what's the result? Like I said, your iOS app dependencies are then packaged into the main app binary. This means that these dependencies, they are available to your app immediately. Of course, there's since the app binary is larger, it does take more time for it to load it from disk into memory, but that process is much faster because it's a standard. It's something that's the system handles without having to do any kind of complicated arithmetic. But these symbols are available to your app code immediately. Now, the app binary will be larger, but that's because the dependencies are packaged with the app itself. The .app archive will be about the same size. And then you will no longer rely on dyld for your third-party dependencies. You will, of course, see, if you use this app launch profiler, you will see that dyld, of course, is working, and that's because of course, you have frameworks that you use, dynamic frameworks that you use. That you used UIKit, you use any of the Apple Apple stock ones. But fortunately, those are probably cached. They're probably available more readily than the ones that you would use in your app package. So this is a result from our migration. We have reduced our app launch time by nearly 50% because of this. And this is shown in the chart as a cold launch time. So this is from a fresh restart of the phone when everything is out of memory. And this is on iPhone XS. Also, profiling, if you're wondering why it's not on a really old iPhone, it is true that it's a bit difficult. It can be a bit annoying to profile lots and lots of times on a very old device because it's just the bus speed can be slower, processing speed is slower. So yeah. There are some disadvantages, for sure. You may have duplicate symbols. This is kind of a common developer, one of these things that we don't want to see, which is a dependency triangle. Depending on how your dependencies are architected, you may find that for example, if you build a library B and a library A separately to ship or to make available to your app module, and in compiling that, you include this utils library, when your app module tries to compile the both library A and library B as its dependencies and link them, it will show that all of the symbols in the utils static library are duplicated. Now there's ways around this, but you may want to just think about, one of the ways is, you can do things like renaming or putting a mask over the, or a prefix at build time over the symbols for one library or for its dependencies. I've seen it done that way. I wouldn't do that. That's kind of weird. Also, that means that they really are duplicated. So that means that the code is actually duplicated in your static library. But if that, you could just package utils along with, if you can, build library B, library A, and the app module together with the utils, and that avoids this situation. However, if you find yourself really struggling with this, the cleanest way is to just maybe keep it as a dynamic framework. That's definitely it's still not a terrible option, but it's not something that also in CocoaPods you see often, but I've seen it more in the dependencies that we have locally or like for our company. Also, for Objective-C, you can say bye to semantic import. In your Objective-C code, as well as your bridging header, you have to replace the use of @import with #import with the actual headers that you need in that file. Now, I know you can define, I'm pretty sure it's possible to define a module for that, but CocoaPods doesn't do this by default, so unless you want to make a module map for each one of these dependencies, I'm pretty sure it's probably it's just easier to include the headers that you actually need in the file. It's actually not super hard. It didn't take more than a few hours to convert the entire app to use this. And also it's Objective-C code, so it's kind of like, hopefully you're not writing extra more Objective-C code, and you're not touching the stuff that exists already too much. But I will say I have a confession to make. So, the title of this talk is lazy loading to launch fast. I'm well aware, maybe people are asking hey, I thought that we could load stuff dynamically at runtime and be all super cool like that. But actually, this is not what you want to do. This was the idea that I had kind of when I submitted the topic, and also when I had initially started out to optimize the launch time in our app, I thought, oh yeah, we can use this DL open because it's made public to the system or to the just through I think it's through the standard library or standard set of headers rather. You can use this to load binary frameworks at runtime when you need them and be all clever like that. You can use that. You can actually use DL open to load a binary framework into memory and execute it at runtime. It is not recommended by Apple, nor is it memory efficient, and it also can cause your app to be rejected from App Store review. Because if you think about it, this is something that, I mean, it's a security issue, right? Like you can basically, if Apple does it, you know, they do the symbol scrubbing, they check on your symbols before they put your app in the App Store, and if they see that, like for example, a string or or whatever is going into the DL open, or it's a variable that's going into the DL open method, then they might flag it as, you know, maybe it's something that got downloaded from the internet and is executed. And I mean, this is kind of like it's not, I don't think it's strictly forbidden by Apple, but it's something that there have been cases of apps getting rejected because of this. So you wouldn't want to use this in your production app. And also, I mean, it's just not necessary. Like most of us have access to the source code of the dependencies that we're using. I mean, if you're using CocoaPods, then you most likely have, I mean, most CocoaPods are compiled from source, and so you can then use the source code to compile the static library. Or if you have, I mean, a lot of closed frameworks or closed dependencies have static libraries available as well. So it's just not necessary. So to improve your pre-main time, what else can you do? You can use more Swift code, use less Objective-C code, and also if you have to, well, okay, so one thing about the advantage of using Swift code over Objective-C is that Swift modules are optimized to be loaded with DOILD. I mean, they've put a lot more effort into, I mean, as far as I can tell, there's been a lot more effort, as makes sense, for Swift code to get into your app executable and get executed by your app than Objective-C. And this is true with either with frameworks and with static libraries. So then there's a second stage, the active state, which is your code. Focus on getting to that first frame. You want to figure out what you are loading once the app is in memory and initialized. And the main goal after the main loop is started, is to get something that's user interactable as fast as possible. So this may not mean that you definitely have to, you know, make all of the functionality available, but something that is actionable. Like, for example, a scroll view with a shimmer on top, or at least some kind of spinner. Because if, you know, I mean, your app probably connects to the network, so it does eventually have to wait on that data coming back. And this, just to show you precisely where it is in the time profiler, or in the app launch profiler, this is this section after the initializing phase. So this is the did finish launching with options, and it's before the foreground active section is occurring. Files, or part of the configuration files synchronously from the network before other things proceed. So that might be something that you could perhaps offload to another queue with lower priority, depending on if you need that in the beginning of your app launch phase. This is another thing that I was really surprised by, and this is also another reason why you should profile your app, always profile your app in release mode, because Runtime performance measurement tools, such as who is using New Relic? Raise your hand. Oh, wow. Whoa, I thought there would be way more people. Who's using any of these live performance measuring tools? Like I think Firebase has one. Has anyone tried it? No? Yeah, okay. Okay, so maybe they're not too popular. But yeah, they can be super expensive on the on launch time, because basically what a lot of these tools do is they swizzle the dispatch methods that to GCD, and will use those swizzled methods to measure how fast blocks will execute, et cetera. I mean, it's a pretty impressive thing, but I mean, this was adding around 300 milliseconds to our app launch time, which is, I mean, we're still using New Relic. We're trying to get off of it, but we are using it at the moment. It is a really amazing service, but there is a cost to a lot of these things. So, but what I would say is, from this dependency side, we all have to use these kind of dependencies. There are a lot of things that get added, or that are our POs and PMs want to add, especially in our analytics people want to add. But it's up to you as engineers to really consider the cost of some of these things. Like, it's not just app launch time. I mean, app launch time is one thing. I mean, you're adding code, you're adding executable code to your app, and you need to consider what kind of space does that take up, and what's the overhead of maintenance, et cetera, et cetera, et cetera. So it's something that you should maybe consider pushing back on more, if there's a reason, or if it comes up that there's a reason to use tools like this. But in general, I would say it is worth it to work to improve your app launch time. You will give your users a great impression of your app. By paying attention to launch time, you will likely use your system resources better, and that means your memory, your CPU, generally. And of course, you'll consider more of what goes into your app's dependencies. That's pretty important. Your app will be better engineered because you'll just be considering it. And how can you then keep that launch time low once you've actually gotten it to an acceptable state? I would say what we've done is we built profiling into our release process, and make sure you save these results. Now, instruments files are huge. Like, they are really large, and you shouldn't leave them sitting on your computer. If you can find the place to put them for in your company's shared drive or something like that, do that. But also don't check them into GitHub unless you really want some extra time to get coffee or whatever. And then you want to save these because you want to compare them from time to time. If you can save the entire instrument trace, then you can go back and see, okay, well, we're having problems with this framework now, or it looks like we're having problems with this framework now on launch time. Was that a problem always, or is this new? And then you can say definitively, it wasn't a problem before, now it's a problem. You can also create unit tests that check your launch time using this new API, XCT, signpost metric application launch. And this is a unit test that you can make, or that you can write, that will basically profile your app startup. I mean, granted, it's on the simulator, if you're probably running your unit test on the simulator, but it's something that you can use to monitor your app launch automatically against previous app launches. And so then, of course, when you add a new dependency, or when there's a new dependency that comes up that somebody wants to add, make sure you profile your app immediately after adding it. Don't let it get to like the release state where you've added a bunch of other code. Just put the app in, or put the binary in, or the CocoaPod in, and immediately profile it. Check the difference. So for you, a few more actionable takeaways. Understand that the older devices that are running your app, and test on a common one. Make sure you have these devices. Like, you should know, of course you should know what type of devices are using your app, but also make sure that you have those devices in your team, and that you are able to use them, and that and make sure that they also have maybe older versions of iOS too, or a common version of iOS that your users are using. Of course, familiarize yourself with the launch time template and instruments. Wherever you can, convert your usage of dynamic frameworks to static libraries, like I said, through CocoaPods. If you're using Carthage, this might be a bit more difficult. I think it's not as well supported, I believe, but we don't use Carthage. But it may be possible. Generally, they might be available as static libraries as well. Make sure that this is just, again, profiling 101. Profile often using instruments and get your team on board with profiling. Make sure people know how to use the tool, how they can use it to improve, and that they're doing it often. Another thing is that I didn't mention, but this is also kind of another good engineering rule of thumb. Optimize your initializers and don't waste compute time on resources you don't need. You don't need to do everything in your init phase, but you'll see that in the app profile. And of course, investigate your third-party libraries and check their impact on launch time. So, thanks a lot for listening, and just come find me if you have any further questions about making our app a huge monolith.